Hi, friends. How's everyone doing? Yeah. My name's Leigh. Thanks so much for coming to the tutorial today. Today we are talking a little bit about something that you may have or you may have not heard about. And then we're going to be fusing that with an idea that you probably have heard about. We're going to be talking a little bit about Nix. We had any Nix users in the room? Oh, wow. All right. So we're in good company. Now, there's like half of the room that raised their hand. And then there's probably another half of the room that has maybe even not heard of Nix or never touched it or used it before. And then I want to sort of paint a little bit of the visions and the possibilities. So I'm going to be real with y'all. I am in the lab right now. Like I am doing a lot of R&D. And I wouldn't say that I'm maybe as experienced of a Nix user as some of the other folks in this room, but we are all in good company, and we're going to run some experiments, learn some principles, and try to hack some stuff together. Does that feel like a good vibe for today? We've got 75 minutes to get our hands on the keyboard and mess around. All right. The other thing that I am much, much more authoritative in is GitOps. Right? So we have Nix, which is a completely kind of separate idea from lots of cloud-native stuff where there's a lot of overlap. Nix is this sort of functional package manager that lets you build reproducible software in a hermetic way. And then you have a bunch of addressed blobs that you can get from caches, and you can assemble your programs with graphs of dependencies. So Nix is all about building software and doing it in a programmatic and a declarative way. GitOps is about declaring your infrastructure in a way that is collaborative and shareable. And so we're going to be looking at Nix. We're going to be using a ease of use layer on top of Nix, developed by the fine and talented folks at Flox. I did used to work with them, so I'm a little bit biased, but I still use their software every day. It's very good. Great way to share Nix with your team. And then I work at Control Plane. Again, my name is Leigh. I think there's two control planes. I'll just get this out of the way. Control Plane IO. And Control Plane employs me to help maintain the Flux project. I know that I just mentioned Flox earlier, and now I am telling you that I work on and have worked on Flux for a really long time. I'm going to do my best to enunciate both awesome projects, both very different from each other, very similar names, but maybe some fun overlap where we could paint a workflow that goes into production all the way to the end, but maybe also starts its story at the very beginning. And I think that that's something that's missing, and that could be really exciting. So we're talking about Nix, we're using Flox, we're talking about GitOps, and we're going to use Flux. Sound good? All right. So the first thing that I want to point you friends to is a repo where I have some experimental things going on. And I think the conference Wi-Fi here in this room, because it's not very dense, is actually pretty fast. But I'm pretty sure as soon as all of us run this speed test, it's going to be a little bit miserable. So if you are comfortable using your free credits in your GitHub account for GitHub code spaces, I recommend coming over to github.com/stealthybox is my repo, and then cryo-nix. Which is a little bit of a teaser for some of the things that I'm experimenting with. And instead of cloning the repo or forking it, and instead of clicking add a code space, you should probably click this 3 dots right here, and you should say new with options. And then you can check it out on main in some region that makes sense for you. And I would recommend bumping up the core count as well as the RAM, just so that things compute a little bit faster for you. This is going to run a Kubernetes cluster, and so it's nice to have a little bit of headroom. That will use your core seconds on your GitHub account faster, so if you are running out of those for some reason, even though it is only the beginning of April, then maybe you just use the 2 cores. It still works. So once you create your code space, or if you don't, yes, yeah, I will go back. Thank you for calling that out there. So the repo is here. There's a green button. You click the green button. You click the 3 dots, and you can say like launch with options. And I recommend clicking 4 cores. And this is kind of like the point where I'm like trying to pre-bake some stuff. So sometimes these code spaces can take a little bit to start up. Some things that are going to be happening in this code space. I will admit that the dev container that I've prepared for you is in an early state. It's not like the most, like perfectly put together dev container, but what it is using is Nix in the dev container. It's using Nix via Flox, which I've mentioned a couple times. And it's using what's called a Flox environment, which has its dependencies declaratively stated inside of the Git repo that you are looking at. And that's going to create the dev container with Docker coming from Nix, providing you your Kubernetes command line tools, providing kind, the Kubernetes cluster itself, as well as a bunch of developer tools, and getting everything set up in the dev container, and then using Microsoft's initRC and hooks and stuff to start the Kubernetes cluster for you, as well as the Nix daemon. So that's just some background as I fill the space to allow folks to create the dev container. I'm going to start moving on, but definitely if you need a little bit more time, please feel free to ask another question. Sweet. So get the dev container spun up. What that will look like is a window that kind of looks like this. You can see I've also been working on some local changes and things, so yours will maybe look a little bit different. But when you pop into here, you'll have a terminal. I'll try to make this big for everybody. And you'll notice that you are going to be at a shell. Your shell will probably look different from mine because I have my dot files loaded. If you're really suffering and you need to import your dot files or whatever, feel free to take the time to do so. I also have a simple bash rc simple. It's like bash rc -simple under my name on GitHub. If you want to clone that, you can use those, and then your repo will look like mine in code spaces. What else was I trying to accomplish here? OK, so you'll pop into here, and you're going to have a code space, and you're going to be in the workspace cryo-nix. I think that you should also clone another repository. So we should go into the workspaces folder and git clone just https://github.com, and then it's going to be stealthybox/scale-nix-gitops. And that should put a repo into that workspace folder. I already have it, so Git is complaining at me. But there is another repository that has other folders with other micro demos that we can play with. So go ahead and get that other repository. I'm just going to leave that up on the screen there. Let's talk a little bit about dependencies and working with people on a team, or even just becoming frustrated with yourself over time working on the software that you like to play with, or the projects that you want to work on. When I want to install a database on my Mac so that I can write software and put information into that database, I usually will need some sort of package manager. I'm either popping into the browser, going to a website, and clicking install on some sort of application, or maybe you get Brew. My teammate uses Ubuntu, and he needs to go and get that same sort of database, probably a different version of it, because the package managers are now kind of out of step with each other. But he's going to use apt, right? And then my teammate is on Arch Linux is going to use pacman. But then maybe they also might want to actually get the same exact version of the package as me, and so they might also use Linux Brew. And maybe they'll have the same version. but it'll be cross-built for their machine, their operating system and CPU, and then I'll have my own version built for me. This gets really frustrating when we have different hardware from each other. And so Docker came and kind of saved the day because we just wanted to pretend that everything was a Linux machine. Unfortunately, that comes with a couple of trade-offs. One, you've got to run a virtual machine and split up your resources. It's not so big of a trade-off because now we have really fast CPUs and stuff, but it can make a difference. And then two, it means that you actually don't get to use the benefits of your operating system kernel and your native hardware. And maybe that might be important if you're doing an ML workload and like wanting to do some GPU computations or something. We, I think, need to get to a place where the system package manager evolves a little bit. Luckily, there's some folks that got ahead of us. So I'm going to move on from having the repos on the screen. Also, please forgive my disorganization. I had to restart my machine right before this entire presentation. So I'm going to try to find things as quickly as possible. But the Nix community has been around for 22 years. This project is huge. If you go to github.com, NixOS, Nix packages, and if you can type correctly, you'll see in here that there is, I had this up earlier. What am I looking for? It breaks the contributor count on GitHub. It's more like 20,000 or something like that. Over 22 years with massive amount of commits. And you can see that over this history, there's a very large, maybe even kind of multiplying or exponentiating trend, some sort of curve that's going up. People really like this stuff. If you've never heard of Nix before, the benefits that it gives you is that your builds are declarative, and then you can maybe start to do operational stuff declaratively. Nix looks like this. It's honestly miserable for anybody whose experience would be, beginning programming Python and just normal stuff that everybody knows. Nix is a functional programming language, and consuming it, oftentimes, it has a reputation for being very hard to grok. So I want to show you maybe an easier way to use Nix and still get the benefits of it. It's an open source project called Flox. They do have like an open service that's similar to Docker Hub as well, where you can push and pull things, but you don't really need to use that part, and we're not going to use it today. We're just going to use Flox to create environments that are reproducible. We're going to consume software from open source, and then we're going to try and use our same habits to build a Go application. Cool. So if you pop into the, also, one thing that's really important here, after you clone both of your repos, press Command-Shift-P to open up the command palette, and then you'll want to make sure that you type the greater than sign, like the little arrow, space, and then you'll want to look for add folder to workspace. You need to click that, and you need to add scale Nix GitOps to the workspace. So that way you have two repos. And when you do that, it's actually going to restart the editor. So if you don't do that, if you pause this code space and come back to it later, you may lose work. So just heads up, that has bitten me before. Let's hop into the scale Nix GitOps repo. Here, I have a software repository. I want to work on my Go application. You'll notice I don't have Go. If I go into my dev folder, scrapbook-dev, then you'll see that I have my source code there. I would like to Go build this, but I can't because I don't have Go. But if I run Flox activate, then now I will be put into a subshell that will have my dependencies. So if you're a Nixian in this room, which there's a pretty impressive percentage of you here, this is no news, right? This looks a lot like maybe running nixenv or activating this thing called a flake, which is a complete jargon term that you've never heard of for the rest of the room. But here what we're doing is activating what's called a Flox environment. And so somebody has prepared a group of dependencies. Let's see what's inside of it. So if I list this Flox environment, then I can see that I have a CA certificate bundle for making sure that my application can do TLS. I have GCC, the GNU C compiler, for doing C binding stuff. I have the Go toolchain for building Go applications. I have the ImageMagick C libraries and development kit. And then I have this thing called package config, which honestly, I don't know what that is, but I downloaded it, I added it to the environment after I had to deal with some errors, and it helps build the ImageMagick libraries when you're doing stuff. So it's necessary. So this is what I need to develop my application. Similarly, if I go up into the folder above and inside of the dev container, you'll see that there's also a Flox environment here. It's called Flox test. It's got ZSH, Nano, Kubernetes Helm, kubectl, kind, JQ for some JSON parsing or whatever you want to do. There's GNU PG for validating, some secret stuff. The GitHub command line tool, Docker, etc. The ACL thing for fixing some file permissions in the dev container setup inside of code spaces. Just all kinds of fun stuff. And this environment is declarative. Let me show you what that means. There is a Flox folder. We'll actually hop back up over into the... Sorry, could you ask that question? I just wasn't listening. Yeah, okay. Cool, I will do my best to slow down a little bit here. So in the scrapbook dev folder inside of the repo, there is a folder that's checked into the repo. It is a hidden folder, so ls-la, that shows you the files inside of the scrapbook dev folder. I just ran the cd command to get in here. There's a folder called Flox, and inside of this folder, there are manifests. And these manifests, I did not write them. Instead, if you want to change things inside of here, you just like Flox install, and then we could say we want to add like Python 3. You can do the same thing with like Flox search. Maybe we could search for some, I don't know, Elixir-related things, or how do you even spell Elixir? Maybe let's just look for Node. So you can get some Node.js runtimes from the catalog. These packages are ultimately backed by the Nix packages cache. And Flox is doing a little bit of work in their service to index them, which means that you can also say like Flox show the name of a package. So like say I did Node.js, you can see the different versions that are available and what CPU and operating system architecture combinations are supported for that particular package version. So this is a package manager that probably feels similar to something you've used before, brew, npm, those sorts of things. We have a question over here from the person in the Pulumi shirt. So basically, those are versions that predate the release of the Apple Silicon Mac. And so historically, those package versions, when they were built on a communal build farm called Hydra, just the CPU and operating system target for ARM64 Darwin, or like basically an Apple Silicon Mac, just didn't exist yet, which is a really good question. For the other ones, the operating system tuple is just not being shown because it's kind of canonically expected that most packages are cross-built for all 4 targets. But if you end up looking in here and you see any architecture combo, then that's a sign that it's not maybe supported on your laptop or your friend's laptop. So this is really interesting because this package manager is showing me a single idea of a package that has multiple versions that then is also supported on multiple operating systems, which is sometimes, I think that that's pretty unusual. It's not unusual if you're just looking at like version manager tools for say Node.js or Go. But it is really unusual when you're thinking about a package manager that has a scope that's as wide as Nix packages, which is like over 120,000 packages. Some of them come directly from programming language libraries, others are command line tools, others are system libraries, a bunch of C toolchain stuff, and even things like systemd and Docker. You can install all of these things with Nix packages, and many of these targets are cross-built. So this is already getting really interesting. What's also interesting is if you run Flox edit, there is a declarative manifest for anything that you do imperatively. When I look at this, I see the design of npm, basically a package JSON. The format of this is called a manifest toml file, and you can edit this as well. So if I wanted to say, I just added Python 3, and if I was privy with, I don't even know what editor I'm in, Nano, then, I'm just realizing some of you probably ran that Flox edit command and then didn't know what editor you were in. I probably should have added the variable to open that up in VS Code. I apologize. If you are in Nano and you are like struggling to get out, you can press probably like Control and X, and that will exit. So just in case anybody got trapped. So there's a declarative manifest, and that means that if I change it and I look at my Git status, then there are changes to those files. And then I can go and diff the manifest change. And you can see now that I've removed a comment here, and I've added, I guess I made an edit, but this was uncommented just a moment ago. It was added automatically and declaratively, and I could, git commit, to push that up to the repo, and then anybody who used this commit would then, whenever they activate that environment, they would now have Python 3 at that particular version. When I say at that particular version, it's a promise. Because if you actually look at the git diff, there's a lock file. Also a huge idea. Like, what a concept. That when I'm working on a project and I would like dependencies and I install a version of a programming language interpreter or some C libraries or a CA certificate bundle, that the hash and the version and the provenance of that decision that I made as a developer to pull a dependency into my software project, that we would lock it. And this is, again, not a new idea. NPM does this. Cargo does this. GoMod works this way. So basically, anybody doing real software development has found this need for per-project dependency management, resolution, and locking. And we just don't treat our machines this way. Nix kind of has this in a thing that's called a flake that's also moderately experimental and sometimes controversial, depending on who you talk to. Flox is not using flakes. It doesn't require them. You can use flakes with this environment format if you would like. I can go and install any flake ref. There's a bunch of Nix people in the room, so yeah, you can install the flake refs. You can do all of your Nix magic. Your years of experience doing functional programming and crafting perfectly tree-shaken software builds, and then just put that into a Flox environment, and somebody does a git clone, and they do a Flox activate, and they have all of your stuff running or even potentially building. So very nice. But these are locked not just for one operating system, but for all of the systems that my environment is declared to support. That's really nice, because this exact environment that I'm using on this Linux AMD machine in GitHub Codespaces, if you go and check this out on your Mac, you will be able to use that exact same environment. So I'm going to increase the font size in a second here. Again, why is this not? I'm in the wrong repo. This needs to be workshop scale. There we go. I need to check the status of where I'm at here right now. Right, I'll push that up. Oh, wow. OK. Hold up 1 second. I have to mount a disk. Look away. I'm doing developer build stuff right now. OK. There we are. Oh, boy. All right. Scrapbook dev. OK. So this is that exact same developer environment right here. Right, the CA certs, GCC, Go, ImageMagick, package config. I can activate it, and then now I have that environment on my stack of subshells, and I have access to Go. Go is coming from my Flox environment. You can see that it's coming from here, and that actually comes from a immutable read-only disk that you saw me just mount. That's part of my Nix installation. That is built for Arch64 Darwin, but this is the same exact Git repo and the same conceptual environment with the same lifecycle of management anytime you change the software project for the Linux AMD 4 stuff, AMD 64 stuff. So, OK. We've thought a little bit about environments. We've talked through kind of what that means. You have the code space cloned. You probably have both Git repos cloned. You have your Git repo added to the workspace so you don't lose any of your work. So just one more time unwinding, since I know that we've kind of gone on a couple tangents. But in the scale Nix GitOps repo, if you go to the scrapbook dev environment, so in this state, and you run Flox activate, you will get the development dependencies necessary for you to run Go build of this application. If you run that command, then it will start to download a bunch of dependencies from the internet. At this point now, I have only one thing to mention to the Nixians in the room, the folks who use Nix already, is that you would probably, if you're very experienced with Nix, write a Nix program to get your dependencies for your Go build. And for people in the room who are not using Nix, I'm just asking you to run a Go build and do a Go mod, basically like hydrate modules the normal Go way. So I would say that this is stepping out of maybe the normal Nix path. But what we are winning is a lot of Nix benefits for everything underneath the developer environment. And nothing is stopping you from continuing to use Nix from here, but just like what's really nice about this is you can get the benefits, or at least a good number of the benefits, but then you don't have to actually ask anybody to learn really anything new at all. So Go build, what you'll end up with if you run ls, I like to run ls-la, is a binary that's built that's just sitting in here. Great, I have my application built. If you look through the source code of the app inside of the scrapbook dev folder, you'll see in main.go that this application is using a Postgres driver. It's using the Go Fiber like web application framework. And then we also are doing some stuff with MIME types. And we are using the Go Graphics Imagick bindings. So these are C bindings from a Go application. And I've done that kind of intentionally because now you're asking for kind of cross-language dependency management, which is the kind of thing that's usually really frustrating and error-prone and cause you all sorts of issues. The beginning of this program initializes Imagick with the C bindings, and then we open up a connection to a Postgres database and listen for a couple of views. And then there's a couple of kind of REST-ish ways to put stuff into a list of things, and then we serve some things from a public directory. And then there's, if you want to mess with the HTML and stuff, you can go directly into views and index and mess around if you were a front-end developer and want to have a JavaScript Go application. Cool, okay, so that's a little bit about the application that we're doing. Let's go ahead and run it. Go image app. Okay, my Fiber server is running. Because I'm using code spaces, it has noticed that my application's running on localhost port 3000. You'll notice we're at a cloud-native conference, and we're currently not using any containers at all. We are using the thrill of localhost. So open in browser, that's great. It's going to go in proximity to my application, and oh gosh, right? I thought things are not working. So I'm just playing a game. I'm totally expecting that because my Go application is trying to connect to a Postgres database, and there's no Postgres database. Let's fix that. I'm going to show you why it kind of is fun to not be inside of a container all of the time. I'm going to do Flox, with my scrapbook dev environment already active. I'm going to run Flox activate -- remote. And then I'm going to say in the Flox namespace, so Flox/Postgres. And then I'm going to pass another flag. I'm going to say start services. And this is going to pull a remote environment that's just kind of ephemeral. And of course, we're doing a live demo, so something didn't work. Why? Is it a flaky problem? Why did that not work? Service manager is unresponsive. Please try again later. Pulling updates from Flox Hub. I could also pull copy this and attempt to run it. I also can just not start the services. There's a couple of things I could do here. I'll be truthful, I was expecting this to be like a wow moment, but instead, 503, yeah, maybe. But I mean, I'm on a code space, you know? Like, this machine is in the cloud. I did get a 503 from the Flox Meta Git repo. That's interesting. What can I do about this? I am going to make a new Flox environment with you, friends. So we're going to make a directory. I'm just going to call it Postgres. And then I should hopefully be able to Flox pull -- copy the Flox Postgres environment. Presumably, if Flox Hub is up right now, then I will be able to do that. If not, I can get it directly from the Git repo. The problem here is that we need a database, and we want to run it. And wow, that's, yeah. OK, cool. Let's go ahead and go get that environment. Flox envs. There's a repo under the Flox namespace called /Flox envs. And if you look through this list, there's Postgres. And basically, I'm just trying to, in Flox Postgres.flox-env, I'm trying to get to this toml file. And we can kind of just copy the entire thing. OK. I wasn't intending or expecting that service to ever go down. That's never gone down for me before. So thanks for suffering through this with me. So what I'm going to do here is I'm in this new folder. I'm going to Flox init a new environment. And then I'm going to set my editor. I think it's like this. And then maybe, does that work? Yeah. There we go. And then I just paste what I just copied. So again, that's from the Flox/Flox-envs repo in the Postgres folder under .flox-env toml, manifest toml. And I'm just going to save that file and accidentally close my code space from muscle memory. And we're just going to Yeah, the upstream repo address. That's a, so that was, Flox/Flox envs. And then in the Postgres folder, there is a .flox. And then there is an env folder with a manifest toml. And we basically just want to copy this. Technically, you should also have like the lock. So if you want, you can just like clone the entire repository. But this should probably work, even just copying the manifest. At this point now, I'm totally just playing jazz. So, but yeah. So once you make a new folder, you can Flox init to create a new environment. Right. So here it's just created the environment Postgres, and then you can also just like open that file. You don't have to necessarily run Flox edit. But that will do like some validation checking, similar to kubectl edit. And basically, so like in this Postgres folder, if you just like edit the manifest toml here, I would just paste it in, save it. And then if you're in here and you Flox activate, then it will want to build that environment. So after activating it, I'm actually going to like exit, and I'm going to show you that you can activate and you can start the services. So environment does not have any services defined. That's really odd to me. OK. I'm like really losing it right now. Thank you. Where are the services in here? Oh, did I not copy the right file? Oh, I see. There we go. I wasn't able to save the file, and then I keep accidentally closing my code space. OK. Cool. So I think I've saved that file. Yes. And then so I just say I want to build Postgres, and then it goes and it makes sure that I have the Postgres package. If it's not there, it goes and fetches the one that's needed for my CPU and architecture from Nix packages. And then it initializes a Postgres database for me, and then tells me, hey, there's some stuff that you should go and try. Here, I'm also going to, so right now I have a database running. Right? So if I run psql, I can actually talk to a database that's running on localhost now. And then I forget, yeah, so you can just type exit if you want to get out of there. I am going to quickly grep through the cluster directory inside of the root of scale Nix GitOps. And I am just going to look kind of recursively for the word, I think recursively and case insensitive, just table. So if you do that grep, or you look inside of cluster appdb YAML, there is a table creation command here. And we're doing local dev, so we're just kind of imperatively messing around. If you copy that command and you go into psql and you paste it, then it will create a table for you. And then now, if you, in your dev environment, if you try to run go image app, which is the thing that we built, then you should be able to open that in browser, and now our app should be running. So what happened here is we have our development environment that's giving us our development dependencies, and then we also have the Postgres environment that we built with the database that initializes itself. And then I logged into the database really quick on my local machine with no authentication or anything. and then added a table. And now our app is working. This is pretty kind of quintessential experience for local development. And what's notable here is that we sort of were stacking. So you'll see at the top of the prompt, or for you it might be at the beginning of the line, and now it's taking up your entire window. It says Flox, and we have the Flox test environment, which has like Docker and all of those things installed for our home directory. And then we have the scrapbook dev environment for my Go interpreter, and then we also have the Postgres database, and then the Postgres database is running a service. So that's, you'll also notice, like you can say, we can, throw some pictures in here and then upload them to the database, and now they're, being serialized and stored within Postgres. So if you, stop the application, now the app's not running, and then, you start running it again, and it'll come back. So that's just like my little scrapbook, which is like a modified to-do list where you can put pictures. The idea as well was that image magic is in the Go application, so maybe if you are really good with the Imagic API, then you can start making the images a little bit more generative in the fun 2000s, turn of the millennium kind of way. Great. So we have our application. I think we should try to think about what we can do to put this in a container. There are some easy ways and then some more experimental ways. So the very first thing I can show you would just be Flox containerize. What this is going to do is it's only going to take the environment, not my application, just only the dependencies for my environment. And it's going to put them into a container. This, honestly, it's I think, an early form and a glimpse of the future. And I guess suspicious ownership. Why would that have occurred? I think that this was the ACL thing. This won't happen to you. My code space is in a very different state than yours because it has been through multiple restarts. But this is a file system permission issue that sometimes happens on GitHub code spaces when they recreate the temp directory as well as some of the device tree. And I have a script inside of the dev container. It's the post create script and probably the post start should have fixed the permissions. The Nix daemon's running. Okay, anyway. I'm expecting that to work. If it doesn't, then I will show it to you on my Mac. Oh, you know what? Why don't I do that just now already, too? So we ran that, and then I also need terminal here. So I'm here with the repo checked out on my Mac. Obviously, because I'm using my Mac, I shouldn't say obviously. All of the binaries that I'm using from Nix packages are built for my Mac. There's no such thing as a macOS container right now that is anything that you would actually want to use. There's some experiments. But if I run Flox containerize, then what will actually happen? Failed to populate Docker. I need to start Docker because I stopped my machine at the start of the session. Let's go ahead and just run that with Colima. It's my favorite container runtime on a Mac. I guess, meanwhile, okay, I need to fix my window management. Here we go. Cool. Back on the code space, Flox containerize completed, and it wrote a container image to the runtime. So this image doesn't actually have my app in it. It only has my dependencies. That means that if I want to actually build something with that, then I need to probably write a Docker file around it, so I can use those dependencies. So I basically have created a base image out of my Flox environment. The cool thing is that I can also run that same exact command on my Mac. What will happen here is Flox will actually resolve the Linux version of all my dependencies, and it'll put it into a volume inside of the Docker daemon. And then it will use that volume to build a container image that is Linux native that respects basically the lock file. So for all of the Mac packages, you'll get the same exact versions of those packages with the same build flags that were built at the same time in a hermetic way on the public build servers that are called Hydra. And then that'll assemble it into a Docker container. You'll see that this process, I wish it was faster. And it's very possible to make this a lot faster. It's just that it's an early sort of prototype of how this works. Some of the ways that you can make it faster would be, I started messing around with a kind of more manual way of doing this. So I have, yeah. Add floxenv generic Docker file. Let's go ahead and push up a commit to the repo. You can pull that down if you have it cloned on your code space. So this Docker file that I'm messing with, let's go ahead and just read the source code. It's dockerfile.floxenv. What this does is from GitHub Container Registry flox/flox. So an installation of Nix with the Flox usability layer on top of it, tagged at just one version ago. So from this image, I'm going to make a working directory, and from my application directory, I'm going to copy my .flox environment into the build context and into the container. And what's really important about this is, if you might have noticed when I looked at where the Go interpreter was, or the Go toolchain was coming from, it was actually inside of this folder, but not actually. It's being symlinked into what's called the Nix store, which is basically a flat directory of a bunch of hashed versions of different, what are called derivations. They're like pieces of packages. And so because everything is actually in the Nix store and it's only symlinked, then when you do this in your Docker file, you're actually only getting the metadata about the environment. So none of the actual binaries or documentation or dynamic libraries are actually being copied into the container here. And then when we're in the container, not on a Mac, but in a Linux machine for Arch64, we can activate the environment, which will go and pull down everything in order to make sure that it's actually runnable. And then here, we can actually query the Nix store. So I'm saying I would like all of the requisites for the runtime environment for my current built system, or my current system from the Nix standard library. And then we have to do a little bit of formatting, and then I also threw a couple wildcards in there because I'm lazy. And then basically, after we get all of the requisites, then these are recursive hard links to all of the files in the Nix store, but in a folder that I can look at separately. And once we have that folder, I tested a few things. This seems to be like the most performant and bug-free way to do this. Then you can call that a build stage, where we basically get all of the requisite store paths for everything that our environment depends on. and then we can copy from that environment and then into the Nix store on an Alpine Linux machine. So this new container that we're producing, it no longer has Nix or Flox or anything needed for Nix or Flox. It only has the dependencies that are necessary for the application's environment. This is effectively equivalent, except the base image is different, to what Flox containerize does. But the benefit of doing it this way is that all of the logic sort of stays in the Docker daemon, and you're kind of only in a Docker file. So if you're using tools that use Docker files, or you want the cache coherency and behavior of the Docker buildx builds, then this is one way to do it. So you can say something along these lines. If I Docker build with this generic Docker file, and then I can name it something like, say, like scrapbook runtime, and then I point it to a folder where the context of that environment is, then you should get a Docker build. So it loads up Flox. I already have it downloaded. That machine is like a gigabyte because it includes Nix and Flox and all of its dependencies. But we're just using that as a builder image. And then we run the Flox activation. Internet's working pretty fast here in this conference center. Lovely. This is, again, happening locally on my MacBook. And then we query the Nix store. We find all of the paths. We make sure that they're recursively hard-linked in a way that's completely isolated from everything else that's not related to it. And then this usually takes like, what, 25 seconds? Yeah. This step could definitely be removed if you just wrote like a buildx front end or did this a different way, like directly with OCI registry as storage. Yeah, we get copied into our new image, and then you end up with, in the case of my Mac, this is an ARM64 Linux image that is runnable. You're in a shell, and inside of Nix store, there's all of my dependencies. Right. So you'll notice I was using Alpine Linux there. It's just so that you have a reliable base for a shell and don't have to go and find the symlink. There should be like bash in here somewhere. ls nixstore grep bash. Yeah, so I mean, like, you could run bash here and set the entry point, and then you wouldn't need Alpine Linux at all. But there's just an alternative way to build those sorts of base images. But we want to be able to get our application to a format where we can actually run it inside of a container. So let's go ahead and look at what that Docker file might look like. This is probably the most kind of standard way to do it. So if you've used Docker before, what's happening here is a multi-stage build. So the first stage is up here, and then as soon as you see another from statement, we're into the runtime, which the last stage is always the output image. So basically, from the scrapbook dev environment that we produced either with Flox containerize or with my special Docker file hack, we're going to enable cgo so that we can use our C bindings with imagic. We have the work directory being set, copy our source code in there, make sure we pull our dependencies. And so we actually run a fully containerized build that's not dependent on anybody's imperative, kind of process or debugging or whatever they did on their local machine. And then we make a new runtime container. So we don't want to have the Go interpreter and all of that stuff in it. We just want our C libraries, ideally. So we have a separate Flox environment that is the base image for this that only has ImageMagick in it. And then we take our Go binary and we can just copy our web assets in there as well as the binary itself. And if we build this, so you'll need to make sure that you have run like Flox containerize on both the scrapbook dev and the scrapbook runtime, or run the Docker file on both of those. Then you can go ahead and run this Docker file, and that's just Docker build and then dot. I've already done this, so it's built the Go application, and you end up with a container image that is usable. You should probably tag it with something. I'm just going to call it scrapbook runtime v1. How about that? So then this container image, you can Docker run it. And, oh, that's right. Did I? Yeah, thank you. Appreciate it. That was exactly the thing that I needed to hear. Thank you. You'd really appreciate that. Okay. There we are. Okay. Go mod, download. That was an interesting one. You have to have a temp directory in order for Go to build. I can't say that I knew that, but I guess when you have minimal container images, sometimes you discover fun things like that. Oh, I should actually unpack something here. I'm like glossing over a little bit of a hack that I've done. So let's go ahead and just dig into that for a second. This run statement right here, in order for this Go build to link up to all of the C binding, for the C bindings to actually call package config and build all of the image magic stuff into the binary itself, we need to make sure that our environment is active. And so a hacky way to do this is inside of our base image. If you look inside of the Nix store for the development environment that comes from Flox, and again, I'm doing a little hack here because this really should be pinned to a hash that's specific to the image. Not that there's more than one in there, there's just one. But and then we run the activate script with the environment from that same thing, and then we can execute Go build. And that allows you to actually build against those bindings that come from Nix. These kinds of wrappers are necessary because since everything actually lives in the Nix store instead of the standard file hierarchy, so like nothing is coming from /lib or /user. There's like nothing to bind against in those directories. We need to have an environment that's specially structured to inform the linker and the loader when programs are built and started where to find their dependencies. This is just kind of an inherent thing about how Nix works. And something like this is, again, a sort of proof of concept kind of hack. You wouldn't want like the final usability to look like this, but conceptually what's happening there is we are hydrating the environment of the build so that it can find all of the C stuff in a non-standard place. The reason that we want to find it in a non-standard place, again, is everything in the Nix store is hashed specifically to the inputs or to the content address of the bits of the packages themselves. And since they're hashed, that means that we can be fully sure every time we build that the exact versions of the things that we want, that our binary will never accidentally get the wrong version of ImageMagick or a slightly different version of glibc. It's always only ever going to be built against exactly what it's supposed to. And then when you run it, it'll only be it doesn't even know how to accidentally find other things. It's just only ever looking for exactly the stuff that it needs. And these sorts of loader hacks and environment wrappers and things like that are in like 99.9999999% of the time like completely free. You never will notice any performance or behavioral difference with your application. It'll just work better than any other time you've had a weird issue where you've had a version skew between something you were using on your Mac and something that got accidentally pulled and updated on some reconciling thing in CI. But you like only found out after an incident. So Has anyone ever had a problem like that? You know, you had a version like slip on you with something that was actively running in production, and then you ran CI to like rebuild something, and then it just like didn't work the same, or the build didn't even work. You know? Yeah. Cool. Seeing a couple of nods. It's like one of the most mortifying problems that you run into. Let's get to a place where stuff is reproducible. So at this point, we have a container that runs our application. Right, like if I were to then I should be able to just run, I think it's like go image app. Yep, cool. And another hack that's happening here is the entry point for this container is actually the Flox environment itself. So you'll notice when I activated the scrapbook runtime environment there, or Docker image, we ended up in a Flox environment specifically for this Go app, and there's a bash shell. So I'll show you what this looks like. Say we wanted to actually run this like just with a single Docker run command. We have to, I think, just pass the binary that we're intending, and then that gets activated as an argument to the activate wrapper. So that way, our Go image application is finding the exact version of ImageMagick that it needs in order to actually run. So that's now we have our application containerized, and there's some caveats about how to start it. Basically, our entry point is not pre-programmed because we need args. So I could have added args to it. But let's look at a Kubernetes manifest for this kind of thing. So in the cluster folder, in the scale Nix GitOps repo, there is an app folder that has a DB YAML and a scrapbook YAML. So most of these things are for illustrative purposes. So ignore the missing, shutdown hooks and things like that you would need, and like missing resource limits and all of that for an actual Kubernetes deployment. But here we have a Kubernetes deployment YAML, and we're calling everything scrapbook. And then we can point it to some container image. Here, this is using a different name and tag than what I built just now. But you could build it at that same name and tag. And then here, we're doing that sort of workaround, right? Like passing an argument so that we can load the binary in a maybe like slightly non-standard way. And then we want to pass it some connection data for a Postgres database. And we'll just tell Kubernetes that there's an HTTP port on 3000, as well as a service that's pointing to that port. And then in the database YAML, there is a config map. Here, I didn't build the database with Nix. You can do that. One of the things that's nice about using the upstream Docker image just from Docker library Postgres is that they do have lifecycle for creating tables. So you can just put a SQL file inside of a config map and then mount it, which is really nice. And then what's also nice, and what was kind of being used by my Go application to connect to my Flox environment's Postgres database, is that there are standard environment variables to direct Postgres drivers to the right place. So my Flox environment was setting these things, and I just copied them, put them into a secret, and then made them appropriate for the Kubernetes service name. There's a little deployment here. Again, this is definitely not a production-ready database. It's exactly the opposite. It's a single replica deployment of a Postgres container instance, so it's not even using a stateful set. And then there's the volume mounts for that table initialization logic. And then there's that. So sort of the full story here is that we would be able to run our application in the Kubernetes cluster. Let's go ahead and Let's go ahead and skip actually like applying this and running this because we have, I think, only a handful of minutes left in this session. Does anyone have any questions about Flox and Nix itself? And we can maybe spend a few minutes on that, and then I have a few closing statements about GitOps. Hi. Yeah, so usually stuff in Nix packages is very up to date. And if we search for the top level Postgres SQL, I think would probably be what we're looking for. So there we go, SQL. Let's go ahead and Flox show Postgres SQL, and then I'm going to pipe it through head, and let's go see what's on top. So currently 17.4 is the most up-to-date package. I would expect that for any high-traffic software, the usage, the user base is incredibly wide and active. If you need to update a package, you can open a pull request on NixOS/Nix packages. Like, you don't need to know anybody. It'll be reviewed by somebody who knows what they're doing. But for packages like Postgres, they have an active community of maintainers specifically looking at that all of the time. And then there are bots and scripts that are constantly looking at upstream places to automatically update these packages. The result is that Nix packages is larger than pretty much any other package repo on the internet, and it tends to be the most up to date. Thanks for the question. Hey. Yeah, SBOMs, I think the story is pretty like it's like begging for an SBOM story, right? And like when you do that Nix store, query requisites, for some, scrapbook dev, Flox runtime environment for some CPU architecture, then you get a list of every required dependency that would ever possibly be touched by applications being run in this way. And that's like a little bit of formatting away from an SBOM. There's no like flag for it right now, but definitely the story is like obvious there. Also, something I would say that it's like kind of weak right now in, I shouldn't say kind of, it's very weak. It's almost non-existent, is vulnerability correlation in Nix packages. Just the way that the packages are maintained and stuff, there's nobody who's like FedRAMP certified, like looking at all these things and trying to correlate them to like does some CVE like apply to this or whatever. But yeah, cool. That's gonna be the last Nix question. I'm gonna take 5 minutes to just talk a little bit about the vision of like GitOps with this. So one really cool thing here is when I update the environment, I get even if I'm working with it imperatively, I get declarative changes to a manifest inside of my project's repository. I do a git push, and then when my teammates come in the morning and they do a git pull and they activate, we're all using the exact same versions of all of our dependencies. So that means that anytime that somebody makes a decision to pull on a new dependency or update something because they want to use a new build flag or a new API or a new feature or subcommand, or they just really want pretty printing for that JSON output that came from AWS CLI and they're putting it inside of your CI script, then any change that we make, it just naturally becomes a declarative consequence of iterating and collaborating with each other. It ends up encoded in the repo. This, to me, has like a really nice mirror to GitOps, where the reason that Kubernetes begs for GitOps is Kubernetes is so wide in scope: networking, cluster management, compute, storage, and often across many, many namespaces, across multiple clusters, multiple organizations, multiple teams and apps. Infrastructure that's like deep and critical, experiments, things that have been there in production and should never change in the next 10 years. Kubernetes, it begs to own all of that. And so people are begging to collaborate on Kubernetes, but ain't nobody walking into the the office in the morning and they're logging into Kubernetes to chat with their teammates. Right? Kubernetes is not a collaboration tool. And so using Kubernetes as a team begs for us to glue collaboration in front of it. Right? And that's what tools like Flox and Argo are really good at doing, is educating people about how the infrastructure works and then giving them an almost invisible thing where it's like you don't even have to look at it. When you are making collaborative changes to your infrastructure, when you're changing code, the robots are always constantly at work reconciling and making sure that exactly what is intended is funneling through the builds, through the lints, through the artifact publishing, signing, verification to your fan out in production. And I think that there's a missing step here, which is that that's everything operational. We need to take GitOps further. We need to shift GitOps left. And I think it starts with how we think about using our machines. Again, I'm really happy to walk people through things. If you would like to continue hacking on these things, I want to be respectful of everybody's time. But in these last 2 minutes, if you look in the scale Nix GitOps repo, there's this cluster folder. And for any Flux users that showed up, there are a couple of new things I would like to show. One is a usage of the open source Flux operator by Control Plane, who, full disclosure, I'm employed with. You can make Flux instances and then point them to a tagged release of the Flux operator manifests for installing Flux at a particular tag version, semver scheme. And when you make this and you install Flux operator and you put this one Flux instance in your cluster, now you have auto-updating Flux. That's really nice if you've got a fleet of 1,000 or a couple hundred clusters or something running on tractors or whatever. The next thing is, okay, well, if we're going to be installing Flux this way, then it sort of feels like it's replacing Flux Bootstrap, which is sort of the bread and butter of anybody using Flux. So a good way to sort of emulate that is we don't have to worry about the installation manifests anymore. Let's just make a Git repo, point it where we're at, create a secret that has a token, and then make our top-level customization. So here you can see the Git repo is pointing to the one that we have cloned. And then it's configured with a token, and it's going to reconcile every minute on the cluster path. So that would be this. Which means that now the Git repo is also managing what version of Flux you're using on all of your clusters, as well as itself, and then creating a namespace for your app, and then deploying our database and our scrapbook application to the cluster using our container image that was built with Nix. And again, that container image, all of the dependencies, they were always version locked from the moment that we used them. So there was never a shift where it's like we went into CI and now something different is happening. And there's never a drift when I'm experimenting on something and then somebody on another laptop pulls down my branch and they're actually using a different version of Postgres. Just these differences, they just can't happen anymore because we brought declarations all the way through the collaboration platform, not just for production infrastructure, not just for ops, but for our development environments too. And I think that could be a cool piece of the future. So thanks so much for coming to the tutorial today. I wasn't expecting a production incident to take down Flux Hub, but there's always cool stuff that happens when you are friends with people at startups. And I'll be around if we want to have a little chat about whatever you guys want to chat about. And thanks so much. Yeah.